Hello and welcome to the 5.7 video proving quadrilateral properties. We all know how much my classes love proofs, and I just want to make sure all you out there that are loving proofs, you have an opportunity to learn to be even better at them. For all those haters out there on proofs, I want to make sure you at least have a chance to be good at them while you're hating them and hating me and wishing geometry did not involve proofs. So I put some notes here. Creating your own proofs requires good reasoning strategies and planning. Now this is a reason why proofs are important, because being a successful person at life requires good reasoning strategies and planning. And one of the best strategies is thinking backwards, and you actually could use this in lots of different things that you do for jobs, for common sense in your daily life, for not being an idiot. Thinking backwards can definitely help you not be an idiot. When you know where you are headed but not where to start, that's when you're going to do the thinking backwards thing. Start at the end of the problem and work backwards. Tons of companies use this to think, okay, we want to get here, we know where we want to get for our brand, for our commercial, for making the product. But how do we start that? Well, instead of figuring out how to start, you start it backwards. We have to get here, let's do the steps backwards, and that'll show us where to start. So when working backwards in a proof, start with the show, or what you're trying to prove. A lot of you still struggle realizing that the last step is always what it says for show or prove. And work towards the given, because they have to give you the show, and they have to give you the given. So kind of an example of this is when you work with mazes. I did this all the time when I was a kid with mazes. I would start at the finish line and work my way back. Here is an example. You are welcome to do this. I would probably give someone who traced this or drew this or made a maze just as complicated as this and then solved it 5 extra credit points. So freeze it if you want to. Pause it if you want to. But here's the proof I'm going to show you. Hopefully this is a moderately quick video. You're given that this kite, this is a kite A, D, B, C, is a kite, which tells you that this is congruent, that's congruent, and that's congruent. But those are also the givens. It says AC is congruent to BC. That's this one and this one. It says AD is congruent to BD. That's this one and this one. So I just marked what they already told you. And it wants you to prove that here's your show, we're starting backwards, that CD, the dotted line, bisects angle ACB. That's this angle right there. So that means if it bisects it, it means this part of the angle is equal to that part of the angle. It's trying to show. So what do? We work backwards. I'm going to kind of flip back and forth. You see that I wrote CD bisects angle ACB. That's our show. That's what working backwards means. So I wrote that down first. That's how I start. And then I slowly figure out, well, how would I have proven that CD bisects ACB? Well, to prove that it bisects it, I'd have to show that ACD, this angle right here, I've already marked this off once, is congruent to BCD. We have to show that those are congruent. That would be the next step. So we say ACD is equal to BCD. Well, how would we have known that? We would have to say what here would tell us that those two are equal. We work backwards and we say angle ADC is equal to angle BDC. Okay, if those two angles are equal, then the first two angles are equal. Okay, that is a harder step, and the reason you need that, is because if they have to be equal for these angles to be equal. Now, what just happened is I had drawn these as angles, and these are actually triangles. So I changed that really quickly. So this was covered. How do we know that angle ACD is congruent to angle BCD? Well, the two triangles would have to be congruent. So I go back to this. ADC, the triangle, would have to be congruent to BDC if we want the angles to equal. So those two triangles have to be equal. That's how we work backwards. And how would those two triangles be equal? Well, you could use one of our shortcuts, side, 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 angle, side, angle, angle, side. As long as it's not angle, side, side, or angle, 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 you can use any of those. Well, in this case, We know CD is congruent to CD by reflexive, and the two givens are AC is congruent to BC, and AD is congruent to BD. So we go back here, and those are our three. So now what we have to do is fill in the reasons, and that's the next slide. So take a look at this and see CD bisects the angle. How do we know that? Well, the two angles are equal. That's a definition of bisecting. How do we know the two angles are equal? The two triangles are equal. How do the two triangles are equal? The three sides are equal. And that's for this proof this works. And here's the reasons. The given, the same segment or reflexive. That's actually should be more reflexive. Side, 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 CP, CTC, and definition of angle bisector. Here is a great example of how to work backwards. That's the end of the notes. Make sure you write down this proof. Make sure you write down these four things, including 5.7 proving quadrilateral properties. If you want extra credit, here's the maze. Hope you enjoy your day.